public health issue. Because I think people just don't care about it enough. It just doesn't, a lot of people feel that they can feel when their blood pressure is high, and you really can't feel it. Your blood pressure can be sky high, and you may never feel it once. So the only way to know is by checking it, and you can check it either by going to your doctor or by having a blood pressure monitor at home. And it's probably the single most important thing that you can do for your health is keeping an eye on your blood pressure and making sure that it doesn't, and if it is going high, and I would say that the average number is around 120 over 80, and if it stays consistently over, say, 130 over 90, and 130 is the top number and 90 is the lower number, and if it stays higher than that, then I think it's worth going to your physician to see what you could do to control your blood pressure.
So there are two things I want to dig into a little bit deeper here. You talked a bit about inflammation, and I feel like inflammation is something I do want to drill into a little bit since you brought it up. There's a lot of research about inflammation and a lot of really splashy headlines about it, claims about it, diets that seek to lower it. I feel like inflammation has become a bit of a buzzword that's been grabbed by some certain industries to, well, sell things. So it's one of these words where I feel like we're starting to, it's kind of running away with itself and becoming a whole industry into itself. So can you unpack the term inflammation a little bit and what we're actually talking about from a medical perspective to help some of the listeners understand a little bit better what might be evidence-based science and medicine versus what might be some of the hype? Because I know it's out there.
All right, so I will explain what inflammation is and how it's connected to heart disease, and then we'll talk a bit, and we'll try and sort through some of the hype versus some of what we know. So inflammation is essentially a product of the body's immune system. So our body has evolved this really, really kick-ass immune system that is always on the lookout for threats. And when we were, really new on this planet and we were still figuring our way out, the big threats that we faced to our survival were three things. They were infections. There were injuries, such as if you got, anything that exposed your blood to the outside world, so getting hit in the head by a rock or falling, from a branch. And the third major cause of mortality was really starvation, because you caught a deer, you had a great feast, and then maybe you'd go a few days without really having a meal. So our body developed very sort of stringent mechanisms to protect us from those things. And one of the sort of global ways that we are able to prevent morbidity from all of these causes is, in fact, inflammation. So obviously, when you have an infection, your immune system is alerted to an outsider that this can rev up the immune system, and it can essentially launch a cascade of functions that can target these foreign entities, essentially. So that's one. But inflammation is also very central to how we fight off injuries. So if you have an injury, for example, a cut, and the immune system will get activated and will form a blood clot that will essentially attempt to seal off this sort of open sort of wounds, so to speak. But the same thing is also true for starvation. So, a lot of our immune system or inflammation or the immune system is actually linked to maintaining adequate amount of nutrition by, in fact, inhibiting some of the basic functions of hormones such as, insulin, which gets rid of glucose in your blood and transfers it into the tissue, while inflammation can, in fact, keep insulin from working, so that you always have sugar in your blood, because your brain doesn't want to go without sugar ever, because it's dependent on sugar for its basic functions. Now, with these three concepts in mind, all three of these are, in fact, directly related to the onset and development and the sort of morbidity of heart disease. So atherosclerosis is primarily an inflammatory process. And one of the reasons why we're seeing a lot of heart disease is that now that we don't have those classic causes of death, such as people don't die of, falling off of cliffs and as much as they used to, I guess. And people don't have as many, again, it's almost a, weird thing to say in the middle of an infectious pandemic, but, traditionally infections as a cause of death have been really dwindling in not only in the United States and other industrialized countries, but really around the world. And people don't die of starvation. If anything, people die of things like diabetes, which are because essentially, and all of these, and so all of the things that we now die of, like diabetes, like hypertension, like heart disease, are in fact because of an immune system or because of persistent inflammation. And yet, and in fact, there is some evidence to suggest that agents that can tame the immune system can in fact reduce your incidence of heart disease. So there's been some recent work done with a drug for gout, which is an inflammatory condition that affects the joints, and this drug is called colchicine. It's been around, forever, and we're seeing that can reduce the risk of heart disease and heart attacks in patients who've had them before. Is it the only reason why people have heart disease? Absolutely not. And in fact, right now, controlling inflammation only offers marginal benefit over some of the established ways that we have of reducing heart disease, such as lowering lowering cholesterol in your diet, or taking cholesterol medications such as statins that reduce cholesterol, controlling your blood pressure, preventing smoking, which again, one of the reasons what makes smoking so bad is that it also revs up the immune system, which can accelerate atherosclerosis, and exercising, which is, I think, probably one of our best ways of controlling, or at least keeping our immune system in check. So, I will say that, a lot of the sort of traditional ways or traditional means that we have had to treat heart disease actually work on some of those inflammatory mechanisms, but we don't have a lot of specific medications or practices that reduce heart disease solely by reducing inflammation, although that might change in the future. Having said that, just going to this sort of idea of hype, and there is a lot of hype about diets that reduce, that are pro or sort of anti-inflammatory, and really we don't have a lot of data for those so far. So, I would say that we know a lot more about how inflammation is in fact one of the key drivers of heart disease, and I did write about this both in the book at great length, but also for an op-ed I wrote for the New York Times last year. But I do think that the way to sort of overcome that is by actually practicing some of the boring things that we've known for a long time, such as reducing blood pressure, reducing cholesterol, stopping smoking, and exercising. So even though we know a lot more about inflammation, the way to sort of address that is actually through some of the sort of things that we've actually known for a long time.
It's always so frustrating for us humans that like immediate rewards to hear that sometimes the solutions are not sexy and long-term. We're not so good with those, are we?
Yeah, they require a lot of work. I mean, and that's what, and those are all the things that it is those non-sexy things, those non-shiny interventions that have actually led to the vast improvement that we've seen in reduction in rates of heart disease. And I know that, there's always that new sort of fancy thing, but really, I think that's what we're really missing. What we're missing is that we're not doing a good enough job of doing some of the basic things that we already know. So, one of the things that I'm really interested in is us regulating salt in processed foods better. We don't do a good enough job, and countries and states that have done a better job have actually led to reductions in how many people have high blood pressure and how many people have heart disease down the road. So because we're so focused on the pill, the magic pill that'll come and will just, fix our problems without us doing anything. And really, it's our lifestyles that have led to this epidemic of heart disease. And unless we address those key sort of things, it will remain the most common cause of death in our society.
I also wanted to talk about statins because that was definitely something you talked at length about in the book, and that seems to be at times a point of high frustration for you in the way that the world or sometimes patients perceive them, or that people are very resistant to them, or that sometimes controversy sprouts up around them.
Yeah, so I'll just say this because I feel like every time someone says something good about statins, they're immediately labeled as a hack for, quote unquote, big pharma. I actually don't receive any money of any sort from any pharmaceutical company or device company in the world. Statins are medications that lower cholesterol in the body, and they are some of the best tools that we have to reduce the risk of heart disease. Like any tool, statins are not a vaccine for heart disease. So it's not like if you take statin that somehow magically you will have no risk of heart disease. And the higher your risk of heart disease, the more benefit you're going to get from statin. So if your risk of heart disease is very, very low to begin with, you're not going to get a lot of benefit from heart disease. But if your risk of heart disease is high, or if you've already had heart disease, then really it's one of the best things that we know that are available. Now, what is the reason why there's so much controversy around statins is because so many people have an indication for statins because heart disease is so common and because our lifestyles are so poor for our hearts, that I think a lot of people have, raised legitimate questions about the benefits of statins, and also their side effects. And I will say that, like any other medication in the world, statins are not free of side effects. But if we actually look at the data, and statins are, I would say probably the best studied medication in the history of science. They're some of the safest drugs we have. A lot of people have concerns about muscle aches and muscle pains. And even though there are some people who will develop sort of significant inflammation of the muscles, a condition called myositis, what really gets a lot more attention is routine muscle aches that a lot of people develop on statins. But really, if you look at the randomized trials in which people were actually blinded from the fact that whether they were getting a placebo versus they were getting a statin, you start to see that there's actually very little difference, if any, between routine aches and pains that people have with a placebo versus a statin. And now, because there's so much misinformation and really essentially, for lack of a better word, fake news about statins, a lot of people have these misconceptions that statins are actually not safe, that they cause a lot of muscle aches and pains, and even just this knowledge, this expectation that you will develop a side effect of statins is actually leading to what's essentially called the nocebo effect, which is just like the placebo effect is an expectation of benefit from a drug, even though it may not have any active ingredient that's doing so. And the nocebo effect is, in fact, the opposite effect, in which if you expect, or if your body expects to have a bad effect from a medication, that it actually is a self-fulfilling prophecy in some ways, that your risk of having that goes up. And a lot of people who are again, this is in no way diminishing the experience that people have, but a lot of these misinformation is being spread by people who have a vested financial interest, that they're trying to get people to take alternative therapies, et cetera, et cetera. The fact is that all major statins are now generic. They are very, very cheap. There's very little money to be made from the sort of pharmaceutical companies for these drugs. So really, I think these are medications that I think that if you are at high risk for heart disease, they are your best friend. They are one of your best friends in reducing your risk of heart disease. And my own dad takes a statin, and after he had a heart attack, and I just told his doctor to crank it up all the way, because the higher the dose, the lower his risk of having a heart attack again.
I have so many things that I would love to talk about, but I know our time is running short. So I'm at a loss of what I can fill our final 10 minutes with. I think probably what I want to talk about is some of for lack of a better term, technology that we have right now in order to deal with heart disease. So if we set aside drugs for a second, the heart is one of the places where we are actually getting in there and like putting stuff in, installing stuff into our bodies. There's a lovely quote, many lovely quotes, but one of the ones in your book that I really liked was, that we often need both a doctor and a mechanic sometimes when it comes to some of the treatments for, heart disease. So I think maybe I would love for you to give us a really quick overview of some of the maybe best known and lesser known kind of modern technology that can be installed to help us out when our heart starts to shudder?
Right. So, one of the beauties of the heart is that at its very core, it is a very basic basic organ, and its main function is essentially to pump blood. So even though there are other organs that look like they're not doing much, like the liver or the kidneys, their functions are actually a lot more complex. The heart is essentially a mechanical pump, and therefore in some patients who develop pretty bad heart failure and that their pump is actually failing, those are patients that end up benefiting from new technologies that's actually developed essentially right in front of our eyes, or in front of my eyes, that didn't exist when I started my medical school career, and that technology is called a left ventricular assist device. And this is essentially a pump that can be planted essentially sutured into a failing heart, and that essentially takes over the function of the heart and pumps blood to the entire body. And so patients who have LVADs, and now tens of thousands of those patients are actually here in the United States, those patients actually, most of them will not have a pulse, because unlike the normal human heart, the blood that flows through an LVAD is continuous. These patients, if their LVAD stops, for example, if they run out of batteries, they actually could potentially die, sometimes within seconds, because they're so dependent on their pump to live. And these patients can live for several years, and you might actually have run across them at the grocery store or when you're out in the mall, and you may not have even noticed, because these patients can carry their batteries in vests that they can wear under their shirts or in small fanny packs around their waist. And to me, this is one of the most fascinating technologies that we've ever developed. Again, the more we raise the stakes, the more we can run into complications as well. And these devices are not come with many, many challenging complications for patients, including a very high risk of bleeding, of strokes, of infections. And yet there are a substantial number of patients in whom this can really extend life and give them years that they may have never seen had this technology not existed. And to me, what is really fascinating about this is in fact one of the first few forays we've made into this whole concept of transhumanism, where essentially we're starting to replace our own sort of mortal organs with technological feats that we just never had before. And really, to me, speaks of the future of medicine, in which we are now starting to blur the boundary that exists between man and machine. And when we have had a lot of times when these pumps don't work, these patients can get very, very sick, and we actually have to call the engineers to come and do their work. So again, I think I think this is that they're presenting a window into the future, and I think requires us to kind of take a pause and appreciate not only what they mean, but also what could be the consequences of what this technological advance could do, and what it means to be a human being.
One of the consequences that you touch on, both when you're talking about LVADs, but also when you talk about defibrillation, in particular defibrillators that have been installed inside the body, is what happens at end of life, because having a piece of machinery inside our bodies doesn't necessarily, and quite often means that machinery is going to keep going after parts of our body are ready to give up, and will just sort of propel it forward, which of course just adds a whole lot of complication to an already complicated time when we're thinking about end of life.
Absolutely. And I think this is why a lot of times what we've seen is that the technological progress can sometimes exceed or, outpace the ethical frameworks that come to define, how do we deal with this technology as human beings. And some of those challenges are sometimes really, really heightened when, the end of, our life is approaching. So a lot of these patients with LVADs, they will die of causes other than heart failure, because their heart failure has been effectively overcome with the LVAD. So they will die of infections, they could die of strokes, in which case one of the final things or final acts that needs to be performed is that their LVAD needs to be turned off. And again, I think it is like any other piece of technology, any type of durable medical technology, that, turning it off does not in fact mean that that the person is, committing suicide or this is euthanasia. It's really in fact just, us in some ways allowing natural death to happen, but it can cause a lot of disconcertation, both for the patients' families or for physicians and doctors, and which is why I really think that, as much as we need to celebrate technology, we just also need to have some of these difficult conversations just so that we're all going into these situations with our eyes wide open, and that we understand what the implications of these technologies are, not just in how they let us live, but what they might mean when we eventually meet our deaths. And which is why I think another reason why I think I wrote the book was to take these conversations not just from the boring medical lecture halls but really introduce them to a broader audience so that we can start having these conversations as a community of people rather than just simply one that's left for academic circles.
The section you have about turning off a defibrillator, and that most people who have them don't know that they can be turned off, don't even know that's an option, that conversation isn't happening. And a lot of those people at their end of their life, they have those really startlingly unpleasant shocks just sometimes minutes before they die, sometimes over and over again. That really, I think, will stick with me as something to make sure that if I need something like that, or someone I love needs something like that, I want to make sure that conversation happens.
Well, and I hope that, as physicians and patients, the more we can all be on the same page, the more we can be part of the same team, and we're speaking in sort of similar terms, I think the more aligned we can be in all those aspects. I think, again, a lot of times, the technology and can move at a much faster pace. Medical interventions can move at a much faster pace, and a lot of times the consequences of what those advances and decisions may not be entirely addressed at the time of when that intervention is performed. And I hope that the culture of medicine does change, and we start having these conversations in a much more transparent way, and really getting our patients along in that conversation rather than just simply being in some ways pedantic or about them.
So we don't have a ton of time left, but I do want to talk very briefly about how you finish the book, which is talking about how concerned you are about our ability to make treatments, whether they're preventative treatments or treatments for heart disease or heart failure as it progresses, to make sure that those treatments and some of the new stuff that's coming out gets out there equally. Because as we know with the world we live in right now, as is being made very clear to us right now with the things that are going on in the world here in 2020, a lot of times it just isn't distributed equally. And definitely at the end of the book, you are thinking very clearly, and it's definitely a thing on your mind. And there's a story there that really stuck with me about a patient who years after a heart transplant had to go off his meds because he couldn't afford them. And it is an absolutely devastating story.
Yeah, I think, heart disease is as much a political condition, an economic condition, a racial condition, as really anything else we have in modern society. Heart disease is not like It's not like COVID that we're waiting for a vaccine that's going to come and save us all. The treatments and for heart disease are readily available that you can get, and everyone should have access to them. And really the struggle is this disconnect between getting those treatments to the people who need them. And a lot of times, the people who need them but aren't getting them are racial and ethnic minorities, are immigrants, are people who have so many other disadvantages in life, and then now also have, and that is that those disadvantages are being manifest in the form of heart disease. And so really, I think reframing heart disease away from just a purely medical problem to one that is essentially a problem of social inequity, of racial inequity, and of economic inequity. I mean, that is the way that we will continue to make progress. Because unless we address those issues, I don't think that we'll be able to really bend the curve any further than we've been able to, because we've had great success in getting all these treatments to the haves. And now the question is, well, how do we get them to the have-nots? How do we get them to every part of this world? Because what we're seeing is that heart disease is rising around the world. So, I'm originally from Pakistan, but if you look at places like India, China, Pakistan, Indonesia, really all developing countries, heart disease is skyrocketing. I mean, we've usually thought about heart disease as a disease of, in industrialized countries, but it is an epidemic that's spreading across the world. And even though we're right now, probably rightfully so, focused on COVID-19, but really, I do feel that one day, and that day may not be far, we can get a handle on COVID-19, and yet we will still be left with this worldwide condition that's on the rise, and is very, very closely linked to the injustices that we see in society. And I do hope that that is the lens that we use to view this condition going forward.
Haider, thank you so much for the time today. Really appreciate it. It was wonderful to have you here.
It was great to get the opportunity to talk to you and your audience about something that, I am extremely passionate about, and I hope that people will pick up this book and learn some of the fascinating stories that I've had the privilege to share.
I hope they do. I wish we could have talked about stents, but unfortunately we can't fit everything in. So if you want to learn about stents, you're going to have to read the book.
Thank you so much, Rochelle, for having me, and thank you to everyone listening in. It's been a pleasure.
If you want to learn more about Haider Varich, his work, his writing, or his most recent book, State of the Heart, exploring the history, science, and future of cardiac disease, you will find links made for clicking in the show notes for this episode and on our website, scienceforthepeople.ca. Thanks for listening, and we'll see you next time on Science for the People. Science for the People is listener-supported. You can find us on Patreon, where you can support us with monthly donations in any amount. Your support keeps us afloat and able to keep making great new episodes, and we thank you for it. The show is produced by Rochelle Saunders and edited by Ryan Bromsgrove. We get help with special projects from K.O. Myers. Our theme song was written and recorded by Fractal Pattern, and its title is Binary Consequence. The show is hosted by Bethany Brookshire, Anika Hazra, Marion Kilgour, and me, Rochelle Saunders.
You're listening to AFM Radio on Astronomy.FM, around the world and beyond.
If you enjoy Astronomy FM radio, please let us know with a small donation. We do rely on your support, and it's true. Every little bit counts.
AFM. You are listening to a universe of possibilities. This is Astronomy FM.
Coming up next, an Astronomy.FM original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy. AFM Radio, AFM Radio, AFM Radio, AFM Radio, AFM Radio.
Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening. This is Julie Tomei, and I am joined by Dr. Elena Hyde.
Hello, hello.
We are broadcasting live from the Alan I. Carswell Observatory located at York University in Toronto, Ontario, Canada. This is Science Night in Canada, where the lineup is all Canadian, starting with ourselves, York Universe, then on to Western World, Quirks and Quarks, and Science for the People. York Universe broadcasts every Monday night at 9 p.m. local Toronto time. That's Tuesday morning, 1 a.m. Universal Coordinated Time. York Universe production works in concert with our online public viewing program run by the Observatory team, which runs between the hours of 9 and 10 p.m. local Toronto time. Head over to www.yorku.ca/science/observatory and follow the links to OPV for online public viewing and join the chat. Our broadcast is powered by and in partnership with Astronomy.FM, the voice of astronomy. For any questions or comments you have about our past shows, or if you have suggestions for future topics, please send us an email at observe@yorku.ca. You can always connect with us on Twitter with our handle at York Observatory, or Instagram, where our handle is at York U Observatory, and Facebook at Alan I. Carswell OBS. All our programs are free, but if you would like to make a donation, please head over to our website and click on the donation button. We will be monitoring the chat room for questions and to post content. The current weather is iffy.
It might not be so bad.
We'll see. I was looking at the clear sky chart. Maybe.
Yes.
Maybe.
It's a big maybe.
Yeah, for new images, but when the sky does not cooperate, the observatory staff has a plethora of archival images. They're always up there, it seems, from the WhatsApp chat, taking new wonderful images. So there will be something over on the online public viewing. How you doing, Elena?
Oh, pretty good. I suppose, like a lot of the other astronomers in Toronto, watching the cloudiness with some skepticism. But there is a chance that it might just clear enough for opening up the 1 meter. Fingers crossed. Of course, the smoky conditions have not been helping either. It kind of creates a lot of haze. So you get haze and clouds. But, I think probably better the first half of the week than the second half of the week. It looks like, double fingers crossed for tonight, because I think in the Ontario area we're due for a little more rain later on, which is our bad word in astronomy, I know.
Although, important, especially for places getting fire.
That's my hope, is that it goes and lands directly on top of all of the fires, and that would solve everyone's problems, really.
So looking at the clear sky clock, tomorrow and Wednesday look pretty promising.
Yes, and we do have some clearing finally. We sort of had a week of rain there for a while. It was just every time we'd go up, it would just start pouring rain on us. But I suppose such is the nature of June in Toronto.
Yes. All right. Shall we jump into our week in space and astronomy history?
Yes. Well, I mean, it's not so much weather related. My first item. I was actually looking through interesting things that were happening in June, and there's a really fun one that was again, astronomers being very bad at naming things. GW 151226 was a gravitational wave signal, which was confirmed on June 15th in 2016. So back not too far in history, but still back in 2016, which is either really, really, really close or kind of far away, I guess, depending on how you feel about it, 2016. So this was a gravitational wave signal that was confirmed. And this was a pretty significant confirmation because gravitational waves were pretty new business. And so if you haven't heard about gravitational waves, these are not like water waves. They don't so much move through material as they are waves of space-time moving, as they are sometimes described. So this is a thing that can happen when you have incredibly compact gravitational objects, much more dense than anything you'd ever find on Earth, which makes it hard to imagine. So gravitational waves are created when you have these incredibly extreme objects like neutron stars and black holes and things that are going to make a dent, shall we say, in the fabric of space-time. And of course, they move around. They can move around each other if they're in binaries, and you could set up sort of a wave. And the theory of a general relativity predicted that gravitational waves would exist, but they're really, really hard to detect. So gravitational waves are something that you couldn't even necessarily see because they're not really a form of light. They move at light speed, but it's a change in space-time. So it had to be detected by this really cool astronomical tool that was built called LIGO. And this involves some very high precision laser interferometry. And it took absolutely ages to build. So LIGO was a large scale physics experiment, or is a large scale physics experiment that was built between 1994 all the way through to 2002 when it had its first light. And this is why, in science, we like to sort of emphasize sometimes these things take a long time. So, if you're looking for instant gratification, physics and astronomy probably isn't the place to go, unless you're out watching the meteor showers or something like that. That's a better bet. So GW 151226, again, nice naming convention. One of the surefire signs that it is in fact from astronomy. This was the second signal that was able to be confirmed out of the LIGO and Virgo collaboration. So they verified the signal on June 15th, 2016. And this was after the also poorly named GW 150914. So that was the very, very first observation of gravitational waves that had ever been reliably made. And it is very exciting. But what was even more exciting is that it then happened again. So we had not just a single gravitational wave event, but we had a repeat. We had all of a sudden more gravitational events. And since that time, of course, LIGO has continued to operate and to detect gravitational wave events, merging binary neutron stars, for example, and all kinds of other interesting things have happened. So I'm actually not sure what their total number of detections are up to date, but they did have some improvements where they had to shut down in 2019, and then they ran through with a new sensitivity range this year. So the 24th of May, which is not that long ago, 2023, this actual year, the new sensitivity for LIGO was actually turned on. So we now have the ability to detect different kinds of gravitational wave mergers, which is really, really exciting. So it means that we can look for different kinds of phenomenon, black holes, neutron stars, white dwarfs, that kinds of things. Usually in binary systems, because it's the change in the gravitational force that sort of sets up that wave signal that we can detect. And we don't detect so much the wave itself as we do its effect on the lasers inside LIGO. So it's really cool. And I just thought I'd give a little shout out to a very important signal, a gravitational wave signal, which was the second verified signal from LIGO on 15th of June 2016. And that was how long it took them, quite a while to actually make the confirmation. But once they had it, it was our second one and counting. So very, very nice. And of course, it's an absolutely huge detector. If you haven't seen it before, the LIGO detector, it's best viewed from aerial photographs. So it's quite a large scale operation with detector sites in Hanford in eastern Washington and Livingston, Louisiana. And the Livingston detector site is, I think that was the first one that was built as from memory. So our viewers our listeners can correct me if I'm wrong. Very, very exciting stuff. And of course, the sensitivity that they have on that gravitational wave detector is what where they say the different types of objects can be found. So the first three detections were all black hole mergers because that's kind of where their sensitivity was set for. Anyways, good times and very lots. I suppose I would just call it fun with gravity.
That's what I used to call it when my kids were really small and sitting in the high chair and just would throw stuff.
That is, yeah.
They're not being pains. They're experimenting with gravity.
It's a very experimental science, you keep throwing things, it just keeps working. Yeah. And that's the other nice thing is, now that we have a mechanism to see, quote unquote, these gravitational waves, we just keep seeing them, and it's awesome.
Yeah. And it's interesting that, the more of these locations that you have, the more events that you can see, because it makes it even bigger, right? So you have these two sites in the States, fairly far apart, but there's also the site in Italy. I think they call that one Virgo.
Yes,
like those data get added in as well, and that makes the detector that much larger.
And you have some kind of localization in the sky, rather than just somewhere in this hemisphere. But yeah, the French-Italian one is Virgo. That was joined in May 2007.
Yeah. I'd forgotten how long it took to build those.
A long time.
Those detectors. That is a long-term project.
Well, that's a long time to have, to ask for funding before you can get the result. And that is one of the hard parts, is because it's so worthwhile, but it's so hard to explain over the decades that it took. This is revolutionizing our view of the universe.
Yeah.
So
it's also harder to explain need, right? Like everyone can go, oh yeah, we need to learn about cancer. I think it might be harder to convince people that yes, we must learn about gravitational waves.
Yeah, well, and it's the discovery is part of the journey, right? And the things that we've discovered looking for this have gone well beyond just, of course, astronomy into optics and electronics and all kinds of areas.
Well, yeah, I mean, just I imagine seismology would have been super important as well.
Absolutely.
Because you have to make up or account for what the Earth is doing to your detector. So interesting.
Fun with gravity.
Well, let's stay with gravity then, because we are going to June 18th, 1976, with the launch of Gravity Probe A. And Gravity Probe A was a space-based experiment to test the equivalence principle, which is part of Einstein's theory of relativity. It was a joint project between NASA and the Smithsonian Astrophysical Observatory. And the experiment sent a hydrogen maser. So that's a laser, but with microwave frequency light. And it was a highly accurate frequency standard, and that was sent into space to measure with high precision the rate at which time passes in a weaker gravitational field. So as many listeners probably already know, mass causes distortions in space-time. If you might be thinking, I didn't know that, Julie, you probably have seen this illustrated as, the ball on the stretched out piece of spandex. It makes the dip around the ball. That's usually the illustration that's used for it. These distortions lead to effects of length contraction and time dilation, where an observer on Earth in the lower gravitational potential, so deeper down in that should measure a slower rate of the passage of time than an observer that is at a higher altitude, so at a higher gravitational potential. The equivalence principle states that a reference frame in a uniform gravitational field is indistinguishable from a reference frame that is under uniform acceleration. So, to give you an example for that, a ball dropped on a rocket ship that's at rest on the Earth's surface will fall at 9.8 meters per second. That's the acceleration due to gravity. Likewise, unconstrained objects in a spaceship that has escaped Earth's gravitational field and is accelerating at a constant 9.8 meters per second square due to the thrust from its rockets will move towards the floor at the same acceleration. So an observer in either situation in the ship wouldn't be able to tell if they were at rest on Earth or in the ship that's moving just from looking at the objects. I'm assuming this spaceship has no windows, and they were perhaps asleep while the ship lifted off.
No sound to the motors.
No sound to the engines. They're anyways, if they're looking, they just have visual data. The maser and the probe was, so the data from the maser and the probe was compared to that from a similar maser that remained on Earth. The Doppler shift was subtracted from the clock rate measured by the maser that was sent to space, and that was done to correct for the relative motion between the observers on Earth and the motion of the probe. And the two clock rates were then compared and then compared against theoretical predictions. And so gravity probe A confirmed the prediction that the deeper in the gravity well, the flow of time is slower, and the observed effects matched the predicted effects to an accuracy of about 70 parts per million. So pretty cool experiment. The theory of relativity is notoriously difficult to test, although it seems like every test that's been put through has confirmed what part of it was testing. So yeah, gravity probe A.
Oh yeah, and this is why I think actually science fiction is quite helpful, because it is very hard to imagine, but you do have ways of sort of framing it so that you can think about it in these kind of imaginary scenarios, because here on Earth we're not going to experience gravitational time dilation. None of us is going to be able to accelerate fast enough to replicate the gravitational forces that would be needed to actually have any kind of time dilation. But, it is still a noticeable effect out in the universe, and especially in like really extreme gravitational situations. There is, of course, the famous astronaut comparison. So, due to this effect, as you mentioned, Julie, of course, if you go up to the ISS, if you spend a long enough time, you will have aged just a little bit less than the rest of us on Earth. So about 6 months on the ISS, you get to age 0.005 seconds less than everybody else. And of course,
that's a huge ordeal for 0.005 seconds.
6 months for 0.005 seconds. And they did have a test back in 2016. You might remember they sent the NASA astronaut Scott Kelly, who had a year-long stay on the ISS.
And his twin was back on Earth.
He had a twin brother, exactly. And he had a twin brother back on Earth. And he stayed a year on the ISS, and he is, due to this, he is technically 0.01 second younger than his twin brother who stayed here. So that's like not enough time for the difference in twin births, I think.
Yeah, I was going to say, which one came out first?
But if he had stayed, for 100 years, maybe. But it's quite fun. So this is why people like it. It's fun thought experiments that will matter a lot if we ever learn how to make micro black holes to power our light speed engines.
Yeah, special relativity and general relativity, like that is stuff to like just twist your brain into knots.
Yeah,
I was knocking on my professor's door several times a week. Sir, I think I get it. Is it this? No. Okay. Explain it again.
It's the math. It's the math that gets you every time.
Oh, I was just trying to get it conceptually, and it was messing me up, let alone the math.
Well, if you get it conceptually, the math will do a fine job of messing up anyone. So don't feel bad about it at all.
Oh, good. I passed, so I can't complain. It was fun though. It was, brain twisty.
And one might even say fun with gravity. Oh.
Yes, exactly. Fun with gravity.
So gravity is not something we can rely on, and yet
I'd say we can rely on gravity very well. It's not going anywhere.
Here on Earth, we are quite gravitationally bound.
We're quite tied to it.
Yes, I am really attached to this planet.
Same. All right, let's move on to our next object that is this. Well,
possibly gravitationally bound.
Possibly gravitationally bound.
Possibly gravitationally
not
bound.
The Earth, though.
No, not the Earth. So this has got a tenuous gravitational connection in more ways than one. So my next little item from history is again fairly recent. This is a kind of a fun one. It's back in June of 2021, so a mere 2 years ago. One of the longest comets ever to be discovered, or longest period comets to ever be discovered, was announced. So this is comet C2014 UN271. So I'm on a roll here for extremely arithmetic. Is that how you say that? Arithmetic names in terms of objects that I'm talking about today. But this comet is a very, very long period comet. It's also sometimes called the Bernstein comet, or BB, which is a very cute nickname. So this comet is thought to have a very, very, very long period. It's from the outskirts of our solar system, and it's been making its way towards our sun for millions of years, all due to gravity. So this is the exact opposite of that super extreme strong gravitational effects we were talking about just a second ago. This is the gravity of our sun at the edge of our solar system, slowly coaxing this object in towards the sun. And it's been on its way for millions of years. And it's thought that this might be one of the most distant comets to be discovered on its inbound journey. So this means that we get to study it for years and years and years before it actually gets into the sun. So I think it still holds the record. I'm sure that people will let us know if it doesn't. But it was first imaged in 2014, and then of course in June of 2021 they had sort of confirmed the announcement, and it's as I say, on the outskirts of our solar system, and we'll call it Comet BB because I think that's a much cuter name than the C2014 UN271. And it was found by combing through about 6 years of data collected by the Dark Energy camera. So this camera was actually doing survey work, and by sending in smarter methods to search through it, we were able to do a lot of data scanning without as many human hours. And this is where astronomers and data scientists make good friends. The camera, known as DECCAM, has actually helped to make a lot of really cool discoveries, and it loves to capture glimpses of comets and trans-Neptunian objects as well. So it's quite fun. And the algorithms used were programmed in. So this is technically in the realm of machine learning type of AI algorithms, and they're sent to the National Center for Supercomputing, and they traced 32 detections to one object. So they figured out that this is an object that is very far away still, but it's on its way. So it's supposed to be, arriving in 2031 at its closest point, and it will be just so I think its closest point is thought to be somewhere around the distance of Saturn. So we'll see. We don't know its orbit that well yet. A lot can change in the next couple of years. So it is only 2023 right now at the time of this broadcast. But it hasn't, wherever this object has come from, it's, as you trace back its trajectory, it's very, very clear that it did come from the outer parts of the solar system. If it had been in before to the solar system, it would have been millions of years ago. So they make estimates based on its trajectory and sort of set limits to say, okay, well, if it had ever come into the solar system before, it wouldn't have been more than 3 million years ago. Just because we can't pin down its path exactly. So it's quite fun. There's a lot to watch. And we have a lot of time to watch it. So it's again, we have all the time between now and 2031 to take pictures of it, to monitor it, and to watch it progress into the solar system, see how far it gets, and see if its near parabolic trajectory will set it in what position and all that good stuff. So it's as I say, very, very different kind of gravitational interaction, very soft gravitational interaction, slowly bringing in this comet. And it's great because, of course, in the history of gravity, comets are actually really important. So I think we've talked about this before in this show. But of course, Halley's Comet, which was originally discovered by the Chinese and used in their comet charts, helped Isaac Newton formulate his law of universal gravitation, which said that gravity doesn't just exist on Earth, but also out there in the skies. So comets and gravity go together very well, and I just thought it would be a fun one because it's a little bit of a different discovery than we usually talk about as well. So here's to Comet BB, or as it's also called, C2014 UN 271. Hope to see it again in 2031.
I had missed this announcement. This is really cool. Set your calendars, folks, for January of 2031. Well,
and it's literally super cool, like so cold, from the icy outer solar system. And it might even start to get a tail. It was imaged by the Hubble Space Telescope last year. Maybe we'll get a JWST image. I'm just throwing that out there in case anyone listening would like to point at it.
Anyone with connections?
Anyone with connections on the inside line would make a pretty good JWST image.
Just about anything would make a pretty good JWST image.
Okay, yeah, that's fair. I actually can't think of any astronomical targets. I'd be like, don't point the JWST as don't point it at the sun, but yeah.
Yeah, definitely don't do that.
Anything else?
There's probably enough things pointed at Earth.
Yeah.
I
think you're not allowed to also because of security laws.
Yeah. Oh, that too. Okay.
Earth security laws.
Yeah.
But this comet would be a great target.
Right. Well, we've got one item left. But before we do that, I do want to tell you that you are listening to York Universe, broadcasting live from the Alan I. Carswell Observatory, located at York University in Toronto, Ontario, Canada. Head over to yorku.ca/science/observatory for chat, questions, content. We're also on socials, Twitter at York Observatory, Instagram at York U Observatory, Facebook at Alan I. Carswell Obs. If you want to join the OPV, swing over to the website and follow the links. It looks like they're in full swing, and they are actually imaging with the 1 meter, it looks like. So go join. Go check it out.
It's pretty cool. That mail-in cam is a lot of fun.
All right, so let's do our last this week item before doing our reminders. So we are going to June 20th, 1996, and this is the launch of STS-78. This was the 5th dedicated Life and Microgravity Space Lab mission for the Space Shuttle program, and it was flown partly in preparation for the International Space Station. This was the 78th flight of the Space Shuttle program and the 20th mission for Space Shuttle Columbia. This was the first space flight for Canadian astronaut Robert Thirsk. The research done on this mission was into the effects of long spaceflight on human physiology, which included 22 life science and microgravity experiments in the orbiter's pressurized life and microgravity space lab module, also known as LN2. 13 of the experiments studied the effects of microgravity on the human body, and 6 studied the behavior of fluids and metals in the almost weightless environment, and the production of metallic alloys and protein crystals. The crew also carried out the first ever comprehensive study on sleep patterns in microgravity, research into bone and muscle loss in space, and in-flight fixes to problem hardware on the bubble drop and particle unit that was designed to study fluid physics. They also tested the use of the orbiter's reaction control system jets to raise the altitude of orbiting satellites. That was a procedure that was later used during the second Hubble Space Telescope surfacing mission to raise the telescope's altitude without damaging the satellite arrays, solar arrays. And it was also used multiple times to boost the orbit of the ISS when it was docked with an orbiter.
Very nice. And of course, all those microgravity experiments have been incredibly useful for all of our talks about Artemis. that have been, we're getting closer and closer to 2024, and they keep saying it's going to happen. So,
I always raise my eye at the, we're going to do this now. Or raise an eyebrow, I should say.
Yeah, we hope they do. It's awfully soon, but I hope it works. And the microgravity experiments in particular, they draw a nice contrast to that 0.005 seconds that you could gain back by staying in space for 6 months. You will also be getting other effects from that microgravity, which, as you mentioned in your bit, some of those are not so good. And the loss of, I think, bone density is one of the ones that they have said is pretty permanent. Sounds like. So, it's not all fun and games up there, folks.
No, spending long periods of time in space to gain a small fraction of a second on your lifespan seems, extreme.
Well, you'll gain that small fraction of a second, but your lifespan might not actually increase because of these other microgravity effects. And I'm not sure I've even read about all the different effects on the, as you say, the metals and the fluid behavior in your body and all that stuff, because a lot of our body is meant to operate with gravity, and so we have trouble with our circulation in no gravity.
I think I get the impression that the metallic alloys and protein crystals, I don't know, was that within the body? I assumed it was just separate experiments. I
believe those
material, we're going up there to mostly test human stuff. But while we're there, let's also do some of this stuff, because it was also to test what kind of experiments can we do on the ISS?
Exactly. Well, the fluid buildup is a real thing, though, because that will actually it's something about your circulation system. I read that before, and it was that it's because of the gravitational field that we live in, we don't naturally have a great deal of trouble going down with our our circulation. It's where we gravity helps us, and then our circulation system pumps fluids back up for us.
Oh yeah. The first few days in space, people's faces are all puffy because
and your skeleton expands, and it's, oh man. Not to talk anyone out of space flight, but you don't underestimate the effects. That's all I'm saying.
Oh yeah, absolutely.
So we have a few reminders, I think, next up.
Yes, let's do it.
All right. So reminders, this week we have, so this is, just checking the date, this is definitely June 19th. So June 21st, we are doing a fabulous summertime atrium tour at the observatory. And by at the observatory, I mean at the atrium, which is on top of the Arboretum parking garage. The weather has been dicey, but it's supposed to be very clear on Wednesday. And we will have a whole bunch of telescopes out. We actually have a brand new mount for one of our smaller telescopes that I'm really looking forward to setting up. Ooh. And it'll be from 9 to 10 p.m. The tickets are free and they're on Eventbrite, so you can go to the website and grab one. It's pleasant, it's warm, it's just kind of late at night because we have to wait for the sun to go down. But I very much recommend the atrium tour if you feel like getting out this weekend. Don't mind staying up a bit late. And of course, I'll also make a little moment to give a small plug for our new observatory posters, which have just come hot off of the presses and are also for sale on the website and the bookstore at York University. They have a Messier poster as well as the Quail First Light, which have turned out really, really well. So that's all the reminders I had, other than just, of course, don't forget to look at all the cool stuff that's up in the sky.
Nice. Does the atrium get buggy? Should people wear bug spray?
I have not seen very many bugs up there. It's the top of a parking garage, so it's kind of just paved. It's possible that there's one or two little bugs might fly by, but there's no trees or greenery around there, so we tend not to get very many. But we did get a raccoon once. But
that's a critter more than a bug.
That's a critter, yes, a varmint, if you will.
Oh, I love trash pandas.
From a distance, yes, they're quite good. And of course, from the top of the parking garage roof on campus, we do get a little bit of light pollution, which is going to be your issue to talk about next. But the bright objects like the moon, Venus, Mars, Arcturus, all those fabulous things that are up nowish, those are all easily viewable even through the small telescopes.
Awesome. Sounds like a great time. I know it's a great time. I've been up there.
You have.
If you are in the Toronto area, go get yourself a ticket. Get on Eventbrite. Find it. Go.
It is quite nice, and even if you could just make out the constellations, doing a little bit of constellation hopping is pretty fun. But I think this actually gets us perfectly to your story, Julie.
Okay, so you want to start with mine?
So let's start with yours, because one of the things you will have to deal with is the campus lights are quite bright, and they do not have any kind of hooding or directionality on them. Yes. Yeah.
So on June 15th, a study was published in Science that provides a comprehensive summary of the harmful effects of light pollution, and it paints a rather grim picture of the future of professional and amateur astronomy. The study goes beyond the effects, the negative effects for astronomy, also looking at effects on human health, wildlife, etc. So we're dealing with more and more light pollution on the ground, but we're also dealing with light pollution from sources in orbit, the mega constellations of satellites like Starlink and OneWeb. Light pollution is a huge problem for ground-based observatories. And just in case the term light pollution is new to you, it is light that is shining upwards into the sky where it is not useful to anyone and drowns out the light coming from the stars. So it's a huge problem for ground-based observatories, and the satellite constellations are even a problem for some space-based telescopes. So according to the study, more than 80% of the world's population currently lives under light-polluted skies. There are, if you look up, light pollution map or something like that, you'll see, satellite images taken of the Earth at nighttime, and you can see where all the population centers are. It's like, oh yeah, there's Toronto, there's Montreal, there's like the entire island of Japan. You can just see the whole thing, all the islands. Like there's the whole country. You can really see where all the big population centers are. Anyway, so 80% of the world's population currently lives under light polluted skies, and light emitting diodes, LEDs, are becoming more and more popular as lights. Those sales have increased by 18% in the last 5 years. They're expected to spike by another 15% by 2027 to reach revenue of $141 million per year. And LEDs have a large amount of blue light, which scatters really well in Earth's atmosphere. And we know this because the scattering of blue light is why the sky appears to be blue. So not that LEDs can't be made in other colors, but I guess we just make them in this blue white light.
They're so bad. They're bad.
I mean, they're good in that they're really energy efficient.
Yeah, no, LEDs are awesome, but the really, really bright blue lights.
But why do they have to be blue?
They're so bad in every possible way. They're incredibly harmful to your night vision.
Yeah.
If you're a driver, you undoubtedly have been blinded by these things.
Yes. I feel like we could have lighting that isn't both energy efficient. Anyways.
Yeah, well, and there's very, very simple fixes. I mean, you can obviously change the color of an LED extremely easily. You can also put what are called hoods or lids across your lights, and they actually have ones that will direct the light down where you want it, so your ground is actually better lit, and it's a huge improvement for walking around. Oh man, and it's just and it saves you energy as well. Yes. So it's cheaper. There's no reason not to do it, and we're just not doing it.
Yeah. The skies and even the most remote places are starting to be affected. And here's a fun stat. 5 to 10% of artificial satellites are gliding over telescope sites at any given time.
Oh no.
Right?
Well, I mean, and we've even seen Hubble get Starlinked.
Well, that's it.
And it's nearly every target you could go to, you have a chance of getting Starlinked right now, and it's become, an action verb that will happen to your data. Just imagine that this is on the one image that you needed, right?
Yeah. Yeah. And as I mentioned earlier, it doesn't affect just science. There are businesses out there that cater to amateur astronomy, to astrophotography, to astrotourism. So there are like dollars and cents involved here. The NASA Vera C. Rubin Observatory, that is a ground-based telescope that's currently being built in Chile to unlock a new era of investigating the cosmos, is going to be it's going to be a wide field telescope. It's going to be looking at a big swath of sky. And it is estimated that 40% of its images are going to have to be discarded because of satellite trails. And this is a telescope that doesn't even exist yet. Like, it's under construction. Half the night sky images that are taken close to dawn or dusk, when a lot of these low orbiting satellites become visible to the naked eye, are contaminated by streaks of satellite trails. In the coming years, about 400,000 satellites are predicted to crowd low Earth orbit. Astronomers have finally started working with other groups to battle light pollution, including the lighting industry, ecological and environmental conservation groups, as well as public policy practitioners. Lighting standards are generally not backed by science. They're just kind of set. And so many, if not most, cities and towns are illuminating their public areas. And not only is it detrimental, it also costs a lot of money, as we've already mentioned, right? You're spending a lot of money powering these lights that are not necessarily needed. A really good example for lighting ordinances is Coconino County in Arizona. It passed the world's first lighting ordinances in 1958 and has since been working to limit outdoor lighting and protect the skies around the Lowell Observatory. So it's been, at the leading edge and groundbreaking on that. So it's been protecting the skies, but also giving the people that live there the lighting they feel they need. So it is possible to find that balance. Artificial lighting disrupts the lunar compasses of nocturnal animals. It impedes their search for food, shelter, and partners. And research has found that light pollution affects human circadian clocks. It makes it harder or longer. It makes it take longer for us to fall asleep. And links have been made to higher risks of obesity and depression. And access to the night sky, like an unlight polluted night sky, is important not just for science, but also for storytellers, artists, songwriters, practitioners of cultural sky traditions, et cetera, et cetera, et cetera. So an important study And I hope that it's something that people move on and that we see the needle move on this in the right direction.
Yeah, well, of course, the best thing is to get your communities involved, because it really does take a whole community or a whole suburb to decide that they're going to get their ordinance changed. And if you're spending so much money on your streetlights and you're losing 70%, 80% of that light up into the atmosphere instead of down on the ground, it's like trying to, air condition your house in the summer with the doors open, right? It just goes outside and it's hugely energy inefficient, and you're not getting what you want where you want it. So you're paying all this money for lighting, and it's not even getting onto the ground where you need to be able to walk. So it's something that I think, communities can tackle, but it would be great if they had some easy ways to do that, because of course we're all familiar with the paperwork struggle of, trying to get these things going and doing it in a way that's going to actually be efficient and give people the light that they want. And of course the satellite problem is a whole nother ball of wax, because that's going to be, that's really kicking up, and it's a safety hazard, because at some point you reach a critical number of satellites in low Earth orbit, and they're going to start colliding, and you're going to get more and more debris clouds, and it's going to get downright hazardous up there.
Yeah. I think that definitely there needs to be some studies done about like what adequate levels of lighting are. You keep hearing about because I think a lot of people are concerned about if it's dark, there'll be crime.
Yeah, and what if you had more light on the ground? just straight up more light on the ground. Is that a bad thing, to have more of the light on the ground? And I think that would be a good place to start. If you had just had more of your light on the ground, would that not be better? And if everybody said yes, we would already have a massive improvement.
Yeah. I have a neighbor a few doors down that it's little LED floodlights all along their walkway, pointed up and in front of, I'm just dude, what are you doing?
Pointed down at the ground. But if you go to buy these lights at the hardware store or something, the default setting is the up pointed light, right?
Yeah.
And that is something that perhaps we could have a longer discussion about, is hey, there are some really nice designs out there that would be amazing and energy efficient and help so many people. Can we not subsidize those or make them cheaper so that those are the cheap go-to option and not the bad ones?
Those are the ones that people buy, maybe.
Yeah, so make it the cheap go-to option.
Work with some designers,
And it seems like there's easy logical solutions, and then you try to see about what you would need to do to get it implemented. But I have heard other communities and smaller neighborhoods having success in this kind of, especially lighting ordinances.
Yeah.
So that gives me some hope.
Well, yeah. And Richmond Hill has some lighting ordinances because of the David Dunlap Observatory, and Professor Jim Laframboise from New York was instrumental in working on with the town on that. So it is possible.
Yes, and of course, over at York University, we're not at all innocent ourselves, as we mentioned before. It's the lights in our campus are primarily pointed up, unfortunately. So we do still see that light pollution, even on top of the parking garage roof. But we have to work around it, and
you have that magical switch.
Yes, I do have a switch for the lights on top of our garage, but not the other buildings. They somehow neglected to give me a switch for all the lights on campus, but it's something that, we're continually working on to see, can we perhaps convince them to put some hoods or directedness on those lights. And I have actually seen a few pop up. So I'm not sure if it's a sign of things to come, but we can hope.
Yes, let's keep up that good fight.
Yeah, right. Every little bit that we do helps that much more.
Absolutely. We've got 5 minutes.
Well, we can talk about light pollution for 5 more minutes, or I can give you a real quick peek into phosphorus, which is the other news item that we had for today.
Let's do phosphorus.
Okay, so phosphorus is one of the coolest, and I'll say cool because it's recently been discovered in a fairly cool place, in Enceladus, or Enceladus. I can't quite remember how you're supposed to pronounce that one. One of Saturn's moons, and probably one of the coolest moons out there. Saturn has a lot of very, very awesome moons, but this moon is literally spewing water out into space. It was captured by JWST. It had a giant water plume, huge water plume, coming out of its surface, and it's ejected so much water into space as it goes around Saturn that it actually kind of has this like water torus of little watery ice particles that it has ejected out, and some of them land back on the moon, but most of them get blasted out. And this water is just being spewed into space. So if you wanted some, you wouldn't even have to land. You could just fly through and have some stick to your spacecraft. So this has been a really interesting place in the solar system for ever since we found out it was literally just had water ice volcanoes. But now it's even more interesting because of phosphorus. Phosphorus is one of the key ingredients for life, and it's one of the things that was found in comets fairly early. So it was one of the reasons why they thought comets might be sort of seeds for life. Solid phosphorus was found in comets, and of course ESA's Rosetta mission playing a big part in that. But now we have phosphorus in an ocean beyond Earth, which is a absolute first. It's a very good sign of, the potential for life on this moon in the oceans that we know are in there. Does it actually have life? We don't know, of course, but phosphorus being a key element for life, and now having been solidly detected, oh my gosh, it is really, really interesting. So you'll hear about this all over the sort of life on other planets chats. We haven't actually uncovered life, but we do have phosphorus now on Enceladus, a tiny moon of Saturn, and it's a very likely place for life. It does have an enormous liquid ocean of water beneath an icy crust. They've found carbon, hydrogen, nitrogen, sulfur, oxygen, and phosphorus, which can team up with sugars to form a DNA molecule. So who knows? We might be able to find something there. It's really exciting. So that's my super, super fast, very exciting. Phosphorus has been found on a moon of Saturn, and it could be found in other places. It's just obviously we don't have the ability to just collect water from other places in our solar system. This is a place that just happens to be literally spewing water out into space so we can see it, which is just kind of awesome. So I recommend everybody to go and look at the JWST image of the giant water plume coming off of this moon.
Very nice. Awesome. All right. So some homework for you listening out there. Everyone, you have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. Your hosts this evening have been myself, Jeannie Tomei, and Dr. Elaine Hyde. Stay tuned because it's Astronomy Night in Canada. Up next is Quirks and Quarks, Western World, and Science for the People. You can always connect with us on socials and on our website. Thank you for tuning in. Clear skies and have a good night.
Good night.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.FM. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.FM. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.FM Radio.
AFM.
Rockets alone are not enough to reach the planets. You're listening to Western Worlds. Hello and welcome back for another conversation here on Western Worlds. My name is Raymond Francis, and I'm coming to you this week, as every week, from the Centre for Planetary Science and Exploration at Western University in London, Ontario, Canada. Space exploration is a demanding field. The conditions and requirements are often exotic and call for specialized expertise. It is rocket science, and also geology, and chemistry, and mechanical engineering and software development, and so many more technical and scientific domains. This tends to mean that the field is populated with engineers and scientists, and often that they are experts in their own particular field, but perhaps not in the other areas of expertise necessary to make space missions work or to understand the universe. So there's room for generalists, and for people who cross the boundaries between those disciplines. And there's also room for people from many other domains of experience. Space law, space commerce, space policy, and space education are all important areas of activity, and call for a different set of skills than astronomy or aerospace engineering do. Western World's John Kissy spoke to Jason Wallace, a conference and events marketing manager with SpaceX. Mr. Wallace's educational and career background aren't what you might first expect from someone at a rocket company, but as John found out, that's all part of how space exploration works.
I'm here with Jason Wallace, who's an alumni of Western University. Tell me a little bit about your background and how you ended up at Western and what you did there.
Yeah, sure. So I'm an American-born student that basically immigrated to Canada and attended the University of Western Ontario. I graduated in 2002. I started in the anthropology program and graduated with my Bachelor of Arts in anthropology. My original goal there was to become a professor and to do research and to travel the world and to excavate things and find things like Indiana Jones, right? But upon graduation, when I started to look at career choices, I had an opportunity to move to San Francisco to do event marketing. And based on that, I spent 12 years at San Francisco doing that, and was eventually recruited by SpaceX to do what I'm doing now in Los Angeles.
And what exactly is it that you do for SpaceX in terms of event marketing?
Yeah, so I have a very exciting job actually. What I get to do is I get to launch products, I get to attend conferences and trade shows, really interact with the customers that are out there who have questions about what SpaceX is doing. At SpaceX, we have a really exciting mandate right now, which is to get people excited about space again. So I think that when the space shuttle was decommissioned, there was really a void left there in terms of getting astronauts to the space station and getting them back safely. And it's taken a number of years for a commercial company to be able to advance to the stage where we are today, and to be able to fill that void and actually offer a spacecraft that will transport astronauts to the space station and return them safely. So I have a very exciting role to be able to interact with customers, interact with the foreign heads of state at rocket launches, and really just sort of get the promotional word about SpaceX messaging out to our core audience.
What's the most exciting moment you've had while working at SpaceX?
Yeah, I think one of the most exciting moments I had was the reveal of the Dragon V2 spacecraft. Of course, this was Elon's reveal to the world back in May. It was sort of a Steve Jobs-esque, unveiling the iPhone to the world. A very exciting, and people were watching from all over the globe, online, live, and in person. And so basically, the coordination and putting all the elements of how we wanted that message and how we wanted this spacecraft to be revealed and viewed by the world. So that was a really exciting, high-level project that I was involved with SpaceX, and very memorable.
Elon Musk is quite an enigmatic character. A lot of people would jump at the chance to work with him. Do you work closely with him? Have you met him? If you have, what's he like as a character?
Sure. I don't know Elon. I've met Elon, but I don't work with him. I don't interact with him on a regular basis. I do have his mobile number. We do shoot emails back and forth from time to time. Obviously, he's got a lot on his plate, but he's a visionary, a once in a lifetime type of a business mogul with a clear vision of the future, and not only that, but the technical expertise to get heavily involved in the development of his products. So, for example, many people don't know that Elon is the chief designer at SpaceX. He's not just the CEO or the figurehead or the primary funder of the company. He's also the chief designer. So he plays a very hands-on role. He's got a clear vision of the future, and he's got such a successful track record that he's the kind of guy that you don't mind following into battle. He's a pretty cool guy. I don't know him that well, but he's a fantastic visionary and a great leader.
A company like SpaceX, people are always aware of the technical side. So they're building rockets, you're building rockets, so we're thinking about engineers, we're thinking about scientists, designers, this kind of thing. So it's interesting to talk to somebody who's not from that technical side. You're highly educated, but your specialism is in anthropology. What's it like working in your role in such a technical company?
Yeah, no, it's absolutely, so I do have a background in tech in terms of working with engineers on a regular basis. This is, of course, a step above even anything that I've done in the past with medical devices and whatnot. It's a real challenge. Of course, you're surrounded by so many brilliant people. We have 4,000 employees at SpaceX, 90% of which are engineers. But, I think that we all bring something valuable to the table, and that's why SpaceX, really looks for certain key characteristics when they're filling a certain role. So if they're going to find somebody that's going to interact with the public on a regular basis and put on events, they're going to need somebody that's socially very strong. A lot of engineers that I know, some are very gifted and are extremely intelligent and also have the gift of gab and can communicate very effectively. But that's not the case with every engineer. Some of them have been very focused on the academic side and are absolutely brilliant, but sometimes might not be quite as strong on the communication side. So, I certainly bring something unique to the table. I can understand and sort of converse and speak technically, but at the same time, I'm not an engineer. Really, my focus is more in the marketing and messaging side. So, really focusing on key messages that we want to communicate to our customers, and be able to, also technically answer the questions that might come back from you whenever you're attending a technical conference such as IAC here in Toronto.
Do you find that you have to learn a lot of the technical engineering stuff so you can talk about it to a certain level, or is it more of a situation where there's somebody who has the technical knowledge and you talk, and then when it comes to saying something that's really technical that people want to know about, you can hand off to this guy? How does that work?
Yeah, it's a great question, John. And the truth is that I have challenged myself, and it's been the biggest challenge for me is to bring myself up to speed on at least a basic technical proficiency. It's very important for me if I'm going to address and speak to engineers and speak to the scientists that attend these type of international conferences, that I have a general understanding of what I'm talking about. Otherwise, they can see right through that. So it's certainly a challenge for myself, and that's. But it's also very exciting because I'll probably be a lifetime student where we're always learning and always trying to improve ourselves. So that's very important. I would say also that when SpaceX does these types of events, they usually go fairly lean. We don't bring a ton of technical expertise, engineers with us, because those guys are focused on getting us to Mars. Those guys are working round the clock 7 days a week. to make sure that we develop the innovation and the technologies to sort of take the next step to making life interplanetary. So they usually don't have enough time to pull them off the production design schedule to send them to events. So it's really up to me to make sure that I'm proficient enough to be able to carry on a reasonable dialogue with intelligent minds.
You did a bachelor's degree in anthropology?
Correct.
Did you go further than that, or did you just...
I did not. After that, what I did was I studied project management at the University of California, Berkeley.
Okay, yeah.
So basically, undergrad in anthropology, graduated in 2002 at Western in London.
Yep.
And after that, went to, while I was working, studied project management at the University of California, Berkeley. Became certified in project management there. And that was the end of my education. I mean, in terms of formal university education. I'll probably, who knows what the future brings, but certainly, my professional life has really taken off, and a lot of the experience and a lot of the things that I learned at Western is I contribute to being a valuable reason why I am where I am today.
I mean, can you give a little bit of an example of that, about how
Sure.
your education at Western has helped you?
Fantastic. No, I think when people think of anthropology, they do think about, sort of maybe Indiana Jones or a professor, sort of similar to what I was pursuing originally. But the truth is, it's a very diverse science. It's a social science, but, it plays parts in scientific method from biology. It pulls a lot of foundations from science. It also has a foot in social science. So the couple of things that it did for me was it provided a lot of the basic biology courses that are involved in getting in the undergrad program. A true understanding of scientific method. I think that's really something that's come into play. Isolating variables and understanding why things turn out the way they do. Asking the right questions. Being able to interpret data. I think that was really important. On the social science side, it allowed me to be able to interact not only with my colleagues who are also, intelligent people at Western. All of our students, it's very competitive to get into the university, and we're all, competing with each other to do better than each other and succeed, in our professional lives, which follows graduation, of course. But basically, the things I learned outside of the classroom with my peers, the understanding of the different cultures that the history that comes behind them, I think that provides me a solid understanding when I communicate with people with different ethnicities from different geographical regions, that I have a basic understanding of their culture, and that I can adapt to that and be able to make sure that I can communicate effectively with them.
Okay. Thanks very much.
No problem. Thanks, John. Pleasure.
You're listening to Western Worlds. Let's go to the discussion.
Well, that was a really interesting conversation that I had with Jason.
Mm-hmm. Dynamic fellow.
And a very interesting background, I thought. That's always an intriguing thing to find out about somebody, how they got to the position that they're in, the place that they're in.
I loved it. Who would have thought from a degree in anthropology, and then be working with one of the only private company to connect up with this International Space Station. And he's really comfortable in the scientific world, isn't he?
He is. He is really comfortable with that, and so it's always interesting when I meet other people like that. They can you can really bring different skills that people who spent their entire career in engineering or science or a particular subject may not have. It's not always the case, but it's the old adage of bringing varied life experience that can be really helpful.
Yeah, I think it's very important for people to kind of know that you don't need to have a certain degree to kind of, do this. Like, you don't have to be an aerospace engineer to be working in an aerospace industry, right? Like, you can bring something of your own that industry, someone who has studied that might not have. For example, an engineer, might not have a very marketing background, or he might, like, you never know. But that's the thing, like, you have something that the industry might not have in itself, and it's different from what all the people are working. He said, like, most of the people working there are engineers.
Indeed, yep. Indeed.
But 90% of them are engineers, so he comes from a different perspective than those engineers who might want to get things done differently,
Exactly.
So that's a complete, different take on, kind of getting into planetary science or getting into, this vast regions of planetary science where you do not need to have a PhD or master's in, planetary science. You can still be involved. You just have to find a way to get that.
I like the point you just made there, because my concern is that in a lot of fields, people find it very difficult to traverse laterally between subjects, because the people evaluating them are expecting a certain background. And it's the same in various companies. You'll find yourself, you'll get to the interview and it will seem like, because you don't have the X and X degree or X and X experience, that you don't even get through the door. I'm always very drawn to stories of people with varied, especially technical expertise. I mean, his background is in anthropology, which gives him an understanding of human history and biology and so on and so forth, and sociology. I think his specialism was in sociology, of course. Obviously, when trying to get those technical ideas across to a public or to investors, then that helps, right? He knows what people want to, what will help in getting that information into people. And he's dealing with very technical information, so that adds an extra layer of difficulty to the situation. Yeah, I mean, it was very interesting talking to him. Yeah, I thought that he was clearly somebody who was enjoying his position and had really appreciated the path he'd taken to get there. So it was quite good.
I found it interesting how his original goal was to become something like Indiana Jones. That's a interesting thought. Now he's with a company that's dedicated to establishing life colonies on other planets. The timing is really good. Mm-hmm. There's movies. The Martian's just come out. The US is dedicated to having sending manned missions to Mars. So this company, this guy, Elon Musk, he's a real visionary. He's got a good product at the right time, I think.
And I think it's not just his. I mean, his is one of the biggest in private industry that has the capacity to go. But there are already startups and small scale businesses that are coming up that are related to space industry and wanting to make things work for bigger companies to go to space, or have contract jobs and things like that for small companies. So there are companies who want to do asteroid mining and who want to go to another planet as a hobby. So there are lots of there's a lot of interest in going to space, and his happens to be one of the biggest ones, and that has acquired one of the biggest contracts with International Space Station. But that's a start. So I guess a lot of people should expect more opportunities in aerospace or space industry with varied background. Exactly. You don't have to be a planetary scientist or an astronaut with an experience, something like that, right? So, really good time.
And that's the point that's really important to mention here, is to try and get across, which is that it's not just the scientists or the engineers that can make a difference in this area. This space industry. The space sector, in terms of science, in terms of exploration, is something that interests a lot of people. In however small a way, there are countless millions of people who never miss an episode of their favourite sci-fi show. They work in an office, writing reports. Mm-hmm. Well, perhaps those people with those kind of backgrounds can still be involved in this area. Mm-hmm. And so with the private industry growing, it's important to realise that there is a growing need for people with more varied backgrounds who have an interest in this. These areas are opening up for those people as well. So I mean, that's really exciting for me. So I've been doing this kind of work for just under 10 years now. I've been in this kind of area, and it's really this is a very exciting moment for me to see that now the requirements are expanding out past people with the super high level, technically refined degrees, and now it's other people who are coming in who are proving just as important. Because of course the person that is involved in the marketing, in the public relations, is the person that is explaining to everybody else what it is we're doing, you know, why we're doing this, why it's exciting, why it's interesting. So yeah, so these people are very important people. So it's nice to see that is happening now.
That's our show for this week. Western Worlds is a production of the Center for Planetary Science and Exploration at Western University. Western Worlds was created by John Moores. This episode was produced by Parshati Patel and featured an interview by co-host John Kissy. Our roundtable discussion featured co-hosts Parshati Patel, Tony Martinez, and John Kissy. Our editors were John Kissy and Parshati Patel, and I'm Raymond Francis. Our theme music is Heliosheath by Sean Kim. You can continue the conversation online and listen to past episodes or learn more about Western Worlds by visiting our website at cpsx.uwo.ca/westernworlds. You can also email us at westernworlds@uwo.ca. On Twitter, we are at wwcpsx, and on Facebook, we are facebook.com/westernworlds. On behalf of everyone here, I'd like to thank you for joining us tonight. I hope you can find world enough and time to join us again right here next time on Western Worlds.
You are listening to a universe of possibilities. This is Astronomy FM.
I'm Keith MacArthur. Unlocking Bryson's Brain is a podcast about my son, the rare disease that keeps him from walking or talking.
I mean, Bryson's perfect, but his life is really hard.
And our family's search for a cure.
Oh my gosh, maybe science is ready for this.
It's part memoir, part medical mystery.
We can do just about anything.
Modifying DNA.
My heart in my throat.
Cure is controversial.
Unlocking Bryson's Brain. Subscribe wherever you get your podcasts.
This is a CBC podcast.
T-minus 10, 9, 8, 7, 6.
E is equal mc squared, in which energy is all steps per man.
The human genome is our shared inheritance, and it is fitting and proper.
Cracks and cracks.
Hi, I'm Bob McDonald. On today's show, it's a fierce, violent, and bloody fight for survival. It's the Woodpecker Wars.
They can do a lot of damage. You can see birds with their eyes gouged out and blood on their plumage. We know that some birds sustain really fatal injuries.
Also, we know bears hibernate and squirrels, but hibernation in squid?
At night, they come up to the surface. They're extremely active. And then during the day, they sink deep into the ocean and live in suspended animation.
Plus, berserker diversity. DNA shows that Vikings were short, swarthy, and Asian. Or at least some of them were.
Seems to be a culture that you could adapt it if you felt for it. Didn't have anything to do with your ancestry.
And how do we make sure a COVID vaccine is safe, effective, and available?
Even under optimistic circumstances, by the end of 2021, we might have enough vaccine for 1 billion people. And the question is, who should be at the top of that list?
All this today on Quirks and Quarks. Okay, it's not exactly a Game of Thrones, but it is pretty close. It's a desperate struggle for succession. It's violent, bloody, and the winner takes all. I'm talking about the Woodpecker Wars. Dr. Sahas Barve and a team of researchers have been studying the remarkable behavior of the acorn woodpecker, a medium-sized bird that lives in oak forests through southwestern North America. Using tiny radio telemetry sensors attached to the birds, they've been able to reconstruct a blow-by-blow story of the violent and bloody wars of succession that break out between groups of woodpeckers competing for territories and breeding opportunities. Dr. Barve is a postdoctoral fellow at the Smithsonian National Museum of Natural History in Washington, D.C. Hi, welcome to our program.
Hi, Bob. Great to be here.
To start with, can you paint me a picture of just what you see when you observe one of these woodpecker wars? What happens?
Imagine you're walking in the oak savanna of California and you suddenly hear a lot of what we call waka waka calls. And you come upon a big tree with probably 40 or 50 birds flying around, and you can see them posturing with their wings open. And you can see birds flying around, birds fighting each other, birds sometimes falling to the ground, holding each other's legs. It's a pretty entertaining and pretty awesome sight.
When you say fighting, I mean, how violent can woodpeckers get?
Woodpeckers get especially violent because they have spears for mouths. And so they can do a lot of damage. You can see birds with their eyes gouged out and with blood on their plumage. We know that some birds sustain really fatal injuries, like a broken wing, and so you can't really expect a bird to live too long with a broken wing. And so these birds get really vicious, and they are just going at it all day from dawn to dusk.
Wow, sounds intense. Well, let's backtrack then, because I understand this all starts with how acorn woodpecker families are organized. Tell me about that.
That's correct. So a lot of acorn woodpecker families in our study population, that's about 50 social groups or family groups. Most of those woodpecker groups have what are called non-breeding helpers. So these birds are offspring of the breeders in the group and help mom and dad take care of and help raise their siblings that are born the next year. And they can stay as helpers for, up to 5 or 6 years.
Okay, so you got these helpers that are the offspring of the breeders. You say breeders, plural. Mm-hmm. How many breeders are there?
Sure. So that's the other cool part about acorn woodpecker social behavior is that there can be many male and female breeders. So each family group can have up to 8 co-breeding males and up to 4 co-breeding females and they all have a communal nest together.
Okay, so we have a family here that has multiple dads and multiple mothers and the offspring who are helping out.
That's
don't
correct.
Breed.
Yep.
Wow. So what happens in one of these families to trigger one of these woodpecker wars?
Let's think of a very simple group with 2 or 3 females and 2 or 3 males and their non-breeding helpers. Now, when all the breeder females die, the helpers are directly related to the dads. So the female helpers cannot become breeders in the same group because then they would have been in an incestuous relationship with their dads. And so unrelated females have to move in to this territory to become breeders, which is multiple, often coalitions of females fighting each other until one coalition beats all other coalitions.
So all the mothers die in one group. We need some new mothers. Those mothers are going to come from other groups, and what? They're the helpers from other groups that wouldn't normally breed in their families. They come over and they'll now fight. The neighbors are coming to fight to become the new mothers.
Exactly. So these are helpers that are coming in from surrounding groups, and they're sort of contesting to become the breeders. Now, let me also make sure that this can happen with both sexes. So when all the male breeders die, the same thing happens. A bunch of coalitions of males who are brothers will come and fight each other until one male coalition beats all other male coalitions.
Boy, sounds like family gang wars going on here.
It is. It is really crazy because the families come in from really far away, and this kind of multi-way fighting is, I think, really rare in nature, where one group has to beat many other groups to win. So I always think of Game of Thrones as being a simple affair because it was always one against us versus them in Game of Thrones. But it's not that way in Woodpecker Wars. It's much more complicated.
Okay, so if all of these helpers from other groups are coming and they're fighting each other to occupy the vacancy that's in this one group that's either lost its males or its female breeders, what are all the other woodpeckers doing during the war?
So the birds that are not fighting, that was a really interesting finding of the study, is that we found that there were a lot of birds present at the power struggle sites which we know could not benefit from the power struggle. And we were really surprised to find all these birds that you wouldn't expect to be at a power struggle still present and spending up to an hour every day, potentially just watching these fights.
So they're sitting in the bleachers watching the fight in the ring. Why do you think they're watching?
Acorn woodpeckers live in really tight social networks, and acorn woodpeckers track how group membership changes for a bunch of groups in their surroundings. So if you play the calls of two birds that are from two different groups, but you play the calls of individuals together, then a woodpecker that you're playing it to will go and check it out. Like, why are these two birds that are not supposed to be together calling together? So they are really inquisitive birds, and they even keep track of birds that have long left the population or have died. So if you play the calls of dead birds or birds that haven't been seen in the area in a year or two, they will respond really strongly and go check it out. It's like, oh, is this guy not? I thought this guy was dead. How is he calling again? And so we know that these birds are really intelligent. They track individuals, and what we feel these birds are getting from watching these power struggles is just to get a sense of which are the big coalitions in the area, who is coming from where, how they're related. It's really difficult to get into the bird's brain and understand what they are extracting from watching these power struggles, but they're definitely watching them.
So when the war is over, what happens to the winners? Are they then just accepted into the family group as new breeders? What happens?
Yes. So it takes a little bit of time, but the winning coalition basically settles into the territory and starts breeding with the opposite sex breeders. Yes. And the other cool thing is because these unrelated females will move in or unrelated males will move in, the opposite sex helpers automatically become breeders. So if I'm a dad with two sons who are helpers and a unrelated female moves in to our territory, then my two sons also become co-breeders with me.
Oh, so it's good for the sons too.
Yeah, so that's why we always joke that if you're a helper in an acorn woodpecker family, you want the opposite sex parent to die so you can inherit the territory.
But I guess it's good from your point of view that you were able to track these birds with the radio telemetry and understand what's going on. Otherwise, it would have been very difficult to see all this with so many birds all just flocking around at the same time fighting with each other.
This study wouldn't have been possible without the use of radio tags. with this really cool technology that we have solar powered radio tags that can stay on the bird for years and years, and we can track all the birds in our population simultaneously and continuously. And so we can use this amazing technology to track all the birds that are fighting at a power struggle simultaneously.
Dr. Barve, thank you very much for your time.
It's been a pleasure. Thank you so much for having me.
Dr. Sahas Barve is Peter Buck Postdoctoral Fellow at the Smithsonian National Museum of Natural History in Washington, D.C.
There's so many squid out here. Absolutely amazing.
As night closed in, this man's fishing trip for coho salmon turned into a stunning and unusual experience. A swarm of jumbo squid emerged from the ocean depths to feed at the surface as they do every evening.
Oh, they're going to look good on a sushi roll.
But it's what they do during the day that's even more fascinating. As morning comes, the squid will abandon the surface and sink back down into deep water. And there they do something strange. They hibernate. But not for a whole winter, just until the next sunset. And now scientists from Ottawa think they know how the squid do it. Here's Dr. Kenneth Story, a professor of biochemistry at Carleton University.
So we study any animal on the planet that can actually drop its metabolic rate to almost zero and live in suspended animation. Squid are a perfect example of that because at night they come up to the surface. They're extremely active. When you're on these big boats, there's huge, giant squid roaring by you. There's sharks, there's sailfish, there's everything eating everything else. And then during the day, they sink deep into the ocean and live in suspended animation. It's cold, it's dark, and they're hiding from sperm whales. So they're very, very quiet.
To study the jumbo squid, Dr. Story has to catch them.
He wants to grab the motor. Whoa.
And reeling in one of these up to 2-meter-long predators is no easy task.
You better be careful.
Job number 1, catch a giant squid.
No, I don't bring him in here. Don't bring him in.
Number 2, don't get bitten by a giant squid. Number 3, don't let them wrap their arms around you because in their suckers, there's little blades. So if their suckers touch you, sticky, like an octopus sucker, they cut a big thing in you.
Babe, don't put your hands down there.
Number 4, put a giant squid into a giant plastic tube. And in that tube, you measure their oxygen and their temperature and their CO2, and then you mimic what's it like at the bottom of the ocean. So you change the water in the tube, bubble it with more oxygen, bubble it with less oxygen, bubble it with CO2, change its pH, change its temperature. So we do the experiments with the animals on board, then we take the tissues, freeze them in liquid nitrogen, and then we get them back to where they're going. The tissues then appear in the lab in -80 freezers, ready to go.
And this is where Dr. Story's PhD student comes in. Hanan Hajmusa took those samples and figured out the secrets behind the squid's ability to hibernate on a daily basis. Ms. Hajmusa, welcome to Quirks and Quarks.
Hi, I'm happy to be here.
Okay, so we've got these squid that are on the surface at night, feeding away. Then they go deep during the daytime to hide. Why do they need to hibernate when they descend into the depths of the ocean?
So one of the reasons the squid do this, along with any other animal that hibernates, is mainly to conserve energy. Because when these squid are going down, 200, 300 meters into the ocean's oxygen minimum zone, they don't have a lot of oxygen, which means they can't really metabolize things the way they would at the surface. So whatever mechanisms they have in place, they have to turn these on and off in a 24-hour cycle. And the thing we wanted to focus on is a field of research called epigenetics. And so what these animals do is they don't change the DNA itself. They instead add little modifiers, so little chemical groups, other little things that have tremendous power in the cell, because what these do is they can essentially act as an on-off switch for that gene. And that way they're able to turn off very specific processes that they don't need, whilst keeping processes that they do need. So extra protections, things like that, they keep those on and running, despite the fact that they have essentially turn down the volume of most of their genome.
Wow. So you're saying that these little chemicals can control the DNA that's being made into proteins?
Yes, yeah. So we went in, we looked at microRNAs, and these are little strands of RNA that act as gene silencers. So if you have them, they'll bind to things and make sure that never becomes a protein.
Wow. Okay, so they're turning things off, but they still have to survive down there. So how much do they shut down? Like, what are some of the processes that get shut down when the squid dive and hibernate?
So the degree that they shut things down is about 52% of global metabolism was shut down, which is a significant amount. We found that they shut down a lot of cell death mechanisms. So there's a fancy word called apoptosis. The way that works is if a cell goes bad, if it gets old, the body kills it. And there's a mechanism, so cell death is cell suicide essentially. But it's a very controlled and energy expensive process. And what we found is at the depths that the squid go to, when they turn things off, they also turn off apoptosis. So they make sure that even though there's cells that should probably make their way out, they turn these processes off because it's not critical to basic survival.
Boy, they're just